question gives you a revenue function, and then they ask you to find where the revenue is maximized. And so it kind of comes out from nowhere that they're all of a sudden talking about maximizing revenue. But here's the idea behind this. Remember that because you have a square power, you have a quadratic equation. And the graph of a quadratic is going to be a parabola. And then as we talked about on the last couple of problems, when we have a parabola, it either opens up or down, and you determine that by whatever coefficient you have on that square power. So here the coefficient, the a value, is -5. And so that means that our parabola, because it's negative, or because a is negative, our parabola is going to open downwards. So if your parabola opens downwards, then at the highest point that you have of the parabola, namely the vertex, that is going to maximize your revenue. So what they're getting at with this question is that, okay, our parabola opens downwards, so that peak point is going to be given by the vertex. Now, to find that peak point, what you would need to do is use, because it's in general form, you would need to use the whole formula of the x vertex is -b over 2a. And remember, the a and the b we're talking about here are the same a and b that we talk about in the quadratic formula. So here, for example, c would be our +0. So our b is going to equal 1280, and then our a will be equal to -5. So you work through that, you get 128. Now, 128 represents the x value. So that's not the total maximizing of the revenue. That, again, is just the number of units that we have to produce to maximize the revenue. So to find the actual revenue, we need to find the y vertex. So to do that, we take our function, which in this case is r, and we plug in 128. So I would have -5 times 128 squared plus the 128 times 1,280, and then times the 128. And when you do that, you will get a revenue of $81,920. And so that is our answer, and that represents the total value revenue for maximization.